My name is Stephen Pettigo. I'm the CEO of OSEI Corporation. We've been mitigating and remediating hydrocarbon-based spills for 23 years. We established the product Oil Spill Leader 2 in 1989. A year later we tweaked it a little bit after the Valdez spill, and we come up with Oil Spill Leader 2, which was a little more effective, a little more faster at remediating hydrocarbon-based materials, including PCBs. Since the Valdez spill in 1989, oil spill response and remediation has basically been stagnant. And during the BP spill, we were able to carry out numerous demonstrations to try to attempt to show how OSE2 could bring oil spill response into the 21st century. And basically, the EPA has allowed the use of chemical dispersants, which the ones they allowed to use are extremely toxic. They ended up sinking the oil into the water column, which depletes oxygen levels, and eventually the oil comes ashore anyway, where you've got to address it a second time. It makes no sense to us to do that. Mechanical spills, which have been utilized since 1969 on spills, the most effective they've ever performed has been in bays where there's very little wave action, and they're basically capable of removing about 8% of the oil from the environment. Now, one of the things you need to ask when you want to clean up oil or hydrocarbon-based material from the environment, and that could be whether it's an ocean setting, freshwater setting, or even groundwater. What you want to do, you want to reduce the pollution level so that, or the toxicity level, so that living organisms can survive. That's why you clean up a spill. Otherwise, there is no reason to clean it up. A lot of people will tell you it's unsightly, but that's not a problem. The real problem is the toxicity of living organisms, which, if a single-cell organism can survive, then the rest of the food chain will be okay. When single-cell organisms can't survive, then that ends up being transferred through the whole system, all the way up to humans. And that's what we found with the BP spill. Now, Oil Spill Leader 2 is a bioremediation product that emulates Mother Nature's own system. And in Mother Nature, when there's a spill, and once again, whether it's lake, freshwater, or groundwater, several things happen when the spill, this toxic contaminant, comes into the environment. The bacteria that are in the system that are directly in contact with the spill end up dying off because the spill is too toxic for them to survive. The bacteria that are not directly in contact but proximal to the spill react in several ways. The first thing they do is they get themselves far enough away so the toxicity won't kill them. They then start releasing enzymes and biosurfactants. And the biosurfactants act upon the chemical molecular structure of a hydrocarbon to start breaking it down so that the toxicity of the hydrocarbon becomes reduced so that the bacteria then can utilize it as a food source. They also release enzymes. These enzymes form protein binding sites on the broken down hydrocarbons, which will induce a myriad of different bacteria to utilize that broken down hydrocarbon as a food source. Now, that's what happens in Mother Nature. And as we've seen with numerous spills, that can take 20 to 30 years. The Valdez spill, there's a lot of it that is still on the seabed floor in Alaska because it's underwater, there's limited oxygen, it's colder, and it takes a long time for bacteria to produce enough biosurfactants and enzymes to break down a spill to utilize as a food source. Now, Oil Spill Leader 2 emulates that process exactly. During our manufacturing process, we extract biosurfactants from single-cell organisms so that when you apply OSE2 to a spill, there's enough biosurfactants that within minutes it starts breaking down the molecular structure of the hydrocarbon. We also produce 156 different types of enzymes because there are various chain hydrocarbons throughout a given crude oil. Some have more longer chain hydrocarbons, some have a lot more shorter chain hydrocarbons. So you need about 156 to cover the full spectrum. OSE2 also has a nutrient system that will rapidly colonize or grow a large amount of bacteria. And once the bacteria runs out of OSE2 nutrients, then it will convert over the only food source left, the broken down hydrocarbons. Now, as you'll see here shortly, Oil Spill Eater 2, as I pointed out, the minute you apply it, it starts breaking down the molecular structure of the hydrocarbon. We cause the oil to float, and we think that's a very important aspect. And this is even including in groundwater. When you cause that to come to the surface, you're now limiting its impact to the system. And in an ocean setting, you sure don't want to sink something into the water column, which will deplete the oxygen, and then the marine species that swim through it will be adversely affected. And then, as we learned with dispersants, when you sink it in the water column, it eventually goes to the seabed and then comes ashore anyway, so you're addressing the same oil twice. With Oil Spill Eater 2, we cause the oil to float, so we're limiting the impact of the spill to the surface area. There's no secondary impacts. Now, we also break down adhesion properties, so any birds or migratory wildlife that come in contact with the oil, it won't stick to them. It will not adhere to them. And then, as I stated, we break down the molecular structure of the hydrocarbon, which then allows single-cell bacteria to utilize it as a food source. The enzymes that in OSE2 form the protein binding sites, so that you don't necessarily need absolute hydrocarbon degraders in the water or in the environmental system, because the enzymes act as catalysts and almost kind of trick the bacteria into utilizing the broken down hydrocarbons as a food source. And then, as I stated, we have a nutrient system that rapidly proliferates the number of bacteria. They then attack the broken down hydrocarbons and can digest it to CO2 and water. We do all this on the surface of the water and lessen the impact of the spill. Now, the Department of Interior tested Oil Spill Eater 2 and compared it to the dispersants they used in the Gulf spill, the Corexit dispersants, and compared it to mechanical cleanup. The Corexit dispersants, now when dispersants used and they talk about it's effective, that's kind of a misnomer, because effective, based on the definition by the EPA, means that you can sink 45% of the oil in 30 minutes. That's it. No end point to that at all. When you're a bioremediation product and you're listed on the NCP list by EPA, you have to substantiate by testing, that GCMS testing, that your product will actually convert oil to CO2 and water, as substantiated endpoint. So, dispersants exacerbate the problem, they don't solve it. Mechanical cleanup, which actually removes the oil from the system, only it can address at best 2 to 8%, leaving 92 to 98% of the oil to cause natural resource damages. So after the EPA or Department of Interior performed their test on dielectric oil and compared the Corexits, the mechanical cleanup, and OSE2, we decided to do a comparison. And we based it on efficacy, toxicity to marine life, toxicity to humans, natural resource damage, and potential litigation, and then finally costs. And what we were able to show is that OSE2 will address 100% of the spill, converting it to CO2 and water, limiting the spill's impact. Dispersants do not clean up any oil. They just sink it. They talk about making it bioavailable. However, the dispersants they use in the Gulf had 2-butoxyethanol in it, which is basically microbial inhibitors. So that oil is entombed and it'll only get taken care of once it comes ashore. So the dispersants don't clean up anything, and as I pointed out, mechanical cleanup will get 2 to 8%. The rest of that will cause natural resource damages. Then we based it on toxicity. Toxicity to marine life. Well, if you keep the oil, you've got an oil spill already, or you've got some type of contamination in the environment. We keep it at the surface, which prevents it from destroying marine species. That protects, and it also doesn't go to the floor, which in the Gulf, there's shrimp beds and oyster beds all up and down the Gulf. And if you're sinking oil into it, then you're destroying that potential life. By keeping it up on the surface, you prevent that from ever happening. So, dispersants increase natural resource damages. Mechanical cleanup actually limits 2 to 8% of the oil from natural resource damage, but 92 to 98% of is creating natural resource damages. And then finally, OSE2 prevents 100% of the natural resource damages by remediating the oil to CO2 and water on the surface. Now, Oil Spill Eater 2 We have 18 toxicity tests, most of them run by the US EPA on anything from Canidia to mycetes, and it shows that our normal toxicological level is somewhere over 1,900 parts per million to 10,000. Corrosive dispersants was 2, which is extremely toxic, and then of course mechanical has no toxicity, it's a removal system. Then we looked at how OSE2 and dispersants would affect human life. And the dispersants they used, by having 2-butoxyethanol in them and DOSS in them, they were adverse to human life. They can cause kidney failure and death and extreme damages to humans. Mechanical cleanup, as I stated once again, eliminates 2 to 8% of the oil, so at least you're eliminating some of the pollution that could potentially be exposed to humans, where OSE2, by addressing 100% of the spill to CO2 and water, limits the impact to humans, and you can handle OSE2 and wash your hands with it and there's no adverse impact. Then, as I stated, we compared to litigation. And when you're creating natural resource damages and you're destroying marine species, there's extreme litigation that follows that. So with Oil Spill Leader 2, you eliminate all the possibility of adverse litigation from natural resource damages. We also did a cost comparison, and we discovered at BP's stockholders meeting in April of 2011, they had set aside $41 billion for the Gulf spill. They reported they'd already spent $34 billion, and this is on a 200 million gallon spill. Well, we did a cost comparison with OSE2, and for every gallon spilled, it takes $2 worth of OSE2 to clean it up, and approximately $2 worth of labor to clean up each gallon spilled. So you're looking at $4 per gallon spilled. So they could have mitigated the entire spill for less than $1 billion, and they'd already spent $34 billion, and now they're up to somewhere around $40 billion. So we think that OSE2 is a great way, a non-toxic means to solve environmental spill problems. And I know this session was on groundwater. We have actually remediated groundwater spills, and one of the most difficult problems we have in addressing a groundwater spill is determining the plume area. But once we determine the plume area and we have access to the spilled contaminant, be it hydrocarbon-based material, then it's a matter of getting contact with it. And we've used OSE2, injecting it into groundwater and adding a little oxygen through on-site aerators. And then in a short time, generally if it's like a fresh crude oil, motor oil, diesel fuel, you're looking at somewhere around 21 to 28 days to remediate that at a temperature of 40 degrees F or better. When it gets lower, it's slower, but it'll still remediate it. And groundwater isn't affected by temperature near as much as surface water is. So we have a system to address oil spills, and we're moving forward rapidly. And if anyone has any questions, I'm open to them.
Thank you. I have a question. So, has it been applied at large scale anywhere here in the U.S. or outside U.S.?
Not in the U.S., but we've been a large scale in South Korea, the Arabian Gulf or Persian Gulf, whichever country you're from. There, off the coast of Nigeria, in Trinidad and Tobago. And when I'm saying large, I'm talking about spills over 25,000 gallons. We've been used on over 18,400 spills on groundwater, soil, concrete, fresh water, salt water, and brackish water for 23 years.
So what is the final product as a result of the remediation? Do you still have that? It's
CO2 and water, and if you're looking at oil that has extreme long-chain hydrocarbons like bunker sea oil or Alaskan North Slope crude, you will end up with some carbon black, some of the foundation carbon, but that's all you'll end up with, is a little carbon black and CO2 and water.
Did you try it to remove free phases in bottom water?
You like gasoline or diesel on the surface?
Yeah, exactly. And on water, three phases.
Yeah, we've done that. There are some special techniques to do that because once again, what you're talking about is depending on the depth of the free phase, you've got an extreme toxic layer there that has to be addressed. That toxicity has to be reduced before that'll remediate, and we have done it. There are times we have to add twice. We have to do a second application because the first application, it just wipes out the bacteria. And by the way, you mix OSE2 with the water like you saw them mixing with the water from the ocean there. If you have an ocean setting, you mix it with ocean water, so you're getting non-indigenous or you're getting indigenous bacteria. You're not adding anything foreign to the environment. There is no bacteria in our product. You mix it with either ocean water if it's an ocean setting, fresh water if it's a fresh setting, or well water if you're treating groundwater. If you can find somewhere lake, river, stream water that would be close. But yes, we will remediate free phase, but sometimes we have to apply a second time because the first shot goes in and starts breaking down the molecular structure. It wipes out the bacteria that we mixed from the water we mixed with OSE2, but then the second application comes in and it'll work just fine. Also, we've run into situations where there's been TCE and PCE in a reservoir of water, and it's so dense it sinks. And what we've done is, and that stuff is very tough to. Part of the problem is when it sinks, it also adheres to the surface or the bottom of the soil. And with OSE2, we've done the same thing where we've had to add a second application because the first application breaks down the toxicity and then causes it to come to the surface of the body of water, even if it's underground. And then we'll add a second application and remediate it. Also, we've run into situations where there's been TCE and PCE in a reservoir of water, and it's so dense it sinks. And what we've done is, and that stuff is very tough to. Part of the problem is when it sinks, it also adheres to the surface or the bottom of the soil. And with OSE2, we've done the same thing where we've had to add a second application because the first application breaks down the toxicity and then causes it to come to the surface of the body of water, even if it's underground. And then we'll add a second application and remediate.